I made 3 videos about quantum computers, listened to a dozen, and I've read a lot of articles. Still now, I don't know what is quantum entanglement. I know quantum entangled particles have opposite measurements, but I don't know where, when. We started headphones. Hello and welcome to yet another episode of the Future Ship. The most thing that lack in those 100 videos, thousands, I watch about quantum computers is, I think, entanglement. Talking about entanglement and how it operates. To understand it, we should take a step back. We should go all the way back to the beginning of the 20th century, when Heisenberg discovered the quantum entanglement. Well, not everybody agreed with him. Einstein didn't. When entangled particles give us these opposite measurements, well, Heisenberg explained it by saying that quantum particles send signals to each other faster than the speed of light, like instantaneously. So they give us the opposite measurements. And here when Einstein disagreed and said that it's not possible to send anything faster than the speed of light. And he explained the action of entanglement by saying, when particles are entangled, they share a code, and we don't know what is this code because we didn't discover it. So the code decides what the particle will give us, what measurement. There is no such a thing as a spooky action at a distance. Well, the problem here is there is no way to prove or disapprove any of these assumptions, theories, until Bell made his famous experiment which proves that Heisenberg's assumption is the right assumption. I will go into much detail in another episode. The thing is, Heisenberg found out a way to separate entangled particles for some bit. He made that possible by have 2 entangled photons, then entangle each photon with separated electrons. Now the electrons are entangled. They give the opposite measurement. So they are separated in a way we could now know if the thing's happening faster than light or not. This is genius. I will still make my episode though. The experiment was done. Einstein was wrong. There is some kind of information sent between those 2 particles faster than light. And now the quantum computer era. There is a bunch of companies trying to make quantum computers. What does it mean to have entangled particles in those quantum computers? Nothing. Absolutely nothing. Thanks for watching. In quantum computers, the particles are ones and zeros at the same time. It's more like a wave of probabilities. The particles have 50-50 chance of measuring 0 or 1. And when we entangle 2 particles, the same applies, but we have opposite measurements. When we tell one of the particles to shift towards 0, for example, the other particle automatically shifts towards 1, and vice versa. And now if we have 4 particles, for example, they will do the same. If we have 5, same. Meaning, if one of them shifted towards 1, the others shifted towards 0. And if we have 20, it will also do the same, and so on. But instead of telling it just to go shift towards 1, that will never work. We make the algorithm translate our language to its language, which is pure physics. That's the quantum computer, my friend. A bunch of quantum entangled particles. That's it. If that is it, how the hell it will make any difference? The idea here is how it gives us the answer. Instead of trying every single one of them like the classic computer, it tries every one of them at once. You know, it is all of them, but shifted towards the right answer. Doesn't seem just hugely faster, but not so fast, my friend. The task here is to keep the particles in the quantum computers entangled, because any interacting with anything, photons or anything, will ruin the entanglement. Every particle do its own thing, causes error and the wrong answers. And that task gets harder and harder every time we add another particle. You know, we want to add this to increase the quantum computer's power. The more particles, the more it could calculate, the more things we could calculate on it. The most important way to keep the particles entangled is to make copies of the quantum quest on different quantum entangled particles on different quantum chipset of quantum computers. So the copy that gets an error the others correct it, and then another one makes an error, and the other one is corrected, and then another one makes an error until the correcting algorithm falls apart. Because after several times, it corrects something wrong from something wrong, which makes the errors happen again. Well, that way we increase the time of entanglement dramatically. Then we can fit another particles in it until we have errors again. Then we find another way to increase the time of entanglement. We put more particles, errors again. Yes, my friend, we are in that place where the idea is crazy good, but the engineering solutions to make it real are developing, but not quite there yet. Just like before inventing the lights, we are one engineering step ahead. In the end, just imagine what could we do if we have such quantum computers. Or don't, just watch my other 2 videos on the benefits of the quantum computers. Okay, the trip is over. Bye.